Hey everyone, welcome back to our channel. Today we'll be talking about what is data compression, how zip, MP3 and video compression work. We'll talk in simple terms so that those who don't have tech background can also understand. So stay tuned. We will start with why do we need data compression? Have you ever wondered why our files are sometimes smaller than expected? It is the magic of data compression. But why do we need it in the first place? It helps us in various stages. First of all, it saves storage space. Data compression saves precious storage space. Imagine storing 10 uncompressed 4K movies that could easily take up a terabyte of our disk. Compressing them reduces the size without significantly compromising quality. Then it helps in faster transfer, as smaller files mean faster transfers. Whether you are uploading a project for work or downloading a favorite movie, compression helps speed things up by reducing file sizes. Then compression helps in efficient streaming. For streaming, compression is the real MVP. By compression, audio and video platforms like YouTube and Spotify ensure faster loading times, even with slow internet speed. There's a fun fact that a single uncrypt, a single uncompressed 4K movie can take up over 100 gigabytes of space. That's like filling up your entire phone's storage with just one movie. Now we'll talk about different types of compression. So there are mainly two types of compression, lossless and lossy compression. Lossless compression means no data is lost during compression. Think of it like packing a suitcase with vacuum sealed bags. Everything fits nearly, but nothing is thrown away. Formats like zip and PNG use this technique to preserve every bit of information, while lossy compression, on the other hand, removes some data to make files even smaller. It's like leaving out extra items when packing your suitcase to save space. Common formats like MP3 and JPEG use this approach. There's a trade-off between lossy and lossless compression. Lossy compression creates smaller files but can slightly affect quality, while lossless compression ensures everything is preserved but takes up more space. PNG use lossless compression, while JPEGs use lossy compression to create small files. Now we'll talk about lossless compression. So the key to lossless compression lies in identifying patterns. For example, instead of storing AAA, that is 6 times A, we can store just 6A. It's a smarter storage without losing a single piece of information. Many popular file formats rely on lossless compression, including zip for files, PNG for images, FLAC for audio, and GIF for animations. These formats ensure nothing is lost in translation. One of the best things about lossless compression is that it's reversible. You can always restore the data to its original form perfectly, nothing is left behind. Here's a fun fact that zip compression was invented in 1989 and is still one of the most widely used compression methods today. It is a timeless classic. Now I'll talk about zip. Zip compression is one of the most popular ways to reduce file sizes. Zip compression works by removing redundant data. Instead of storing repeating data, it stores references to those parts. The magic behind zip compression lies in powerful algorithms like Huffman and Lempel zip Welk or LZW for short. These algorithms efficiently find patterns and encode data to minimize file size. Zip compression works best for text, code, and documents, where patterns and redundancies are common. Here's a fun fact that zip file can act like a mini folder containing multiple compressed files within it. Now we'll talk about lossy compression. So lossy compression is all about making files smaller by removing unnecessary data. Lossy compression reduces file size by limiting data we don't notice, much like extra color shades in an image or sounds outside human hearings. This makes files significantly smaller. Some of the most popular formats like MP3 for audio, JPEG for images, and MP4 for videos rely on lossy compression. These formats balance quality and size to make sharing and storage easier. The trade-off with lossy compression is that it's not reversible. Once the data is removed, it's gone for. This is why lossy formats are best for situations where smaller size matters more than perfect quality. Your phone's camera likely uses lossy compression to save storage space. That's why you can take so many photos without running out of memory. Now I'll talk about MP3 compression. MP3 compression revolutionized the way we listen to music by shrinking audio files while keeping the quality almost intact. The first step in MP3 compression is removing sounds that humans can't hear. These include frequencies beyond the range of human hearing, typically above 20 kHz. Next, MP3 uses perpetual coding, a smart technique that prioritizes important sounds like vocals and melodies while de-emphasizes less notable, less noticeable audio. This process can reduce audio file size by 80 to 90%, making it easier to store and share music without a major loss in quality. The MP3 format was introduced in 1991 and it completely transformed the way we enjoy music. It paved the way for digital music libraries and streaming services. Now I'll talk about JPEG. JPEG compression is a clever way to make images files smaller while keeping them visually appealing. JPEG reduces file size by simplifying color details. Instead of storing every single shade, it keeps only the most important colors, saving storage space without much visual change. At the heart of JPEG compression is the discrete cosine transform or DCT. This process converts an image from pixels into frequency data, making it easier to compress. The more you compress a JPEG file, the smaller it gets, but at a cost of lower quality. Extreme compression can lead to pixelation and visual artifacts. A JPEG file can be up to 10 times smaller than a MP image while maintaining nearly the same quality. That's why JPEGs are so popular for photos. Now I'll talk about video compression. So video compression makes it possible to watch HD and 4K videos without filling up all our storage. Instead of storing every frame fully, video compression uses keyframes and predictive frames. Keyframes are like snapshots while predictive frames only store the changes between frames. Compression also reduces the bitrate which control how much data is used per second of video. This helps balance file size and quality. Popular compression formats like H.264 and H.265 are used for everything from streaming HD movies to saving 4K video files. H.265 is newer and even more efficient for ultra high definition videos. Without compression, a 1 minute 4K video could take up several gigabytes of space. Compressions make video streaming and storage practical for everyone. That's all for today. If you find this video helpful, then like the video.